So, do you guys know what quadratics are? What was that? No? Okay. So, let's review what quadratic functions are. Alright. So, quadratic functions form this shape. So, if you've ever seen a graph before, you've probably seen this shape, right? Where it has two x-intercepts. So, is everybody familiar with the shape on screen? Okay, so as we know, a quadratic Edwarski, I was just asking if there's anything you guys want to learn, or if you guys are okay continuing with learning about the line. So, is there anything you want to, like, anything specific you want to learn, or no? Okay. Yeah, so we're just going to continue talking about intersections between quadratic functions and linear functions. That's our main focus for this class. So, quadratic functions usually come in two different shapes. Not shapes, two different forms. So it could either look like that, or it could either look like this, right? We call the first one concave up, right? And then concave down. So, for one of the functions, quadratic, like for this one, the possible equation for this one could be x squared, right? Well, this one could be negative x squared. This is what's called a transformation, as it reflects over the x-axis, right? So, and an easy way to identify quadratic functions is just by seeing this little squared, right? And you guys have probably solved quadratic functions. I just want to review to make sure everybody knows how to solve quadratic functions before we move on to the harder topics in class. So I'll just give you questions and I'll see how you guys do, okay? So I want you guys to find the x-intercept of this, and then I want you guys to find the vertex for this one. Oops. Alright, do you guys think this is doable? So I have 4 questions on the board. Not 4, sorry, 3 questions. We've talked about this in previous classes as well, but I just want to review to make sure you guys completely know what it is, because we're going to be working a lot with this. So, I'll give you guys like 5 minutes to solve these quadratic functions, and let me know when you're done, okay? Did everyone get that? Swahiti, Dwarsky, Anushri. Yeah? Okay. So let me know if you guys need help, but I'll give you some time to solve this. Okay, so I see one of you guys have finished. How much more time does everyone else need? Initially, so ID, how much more time do you guys need? Okay. Alright, awesome. So it looks like everybody's finished. Um, so let's work on these problems together, just so I know that everybody's clear on the thought process. So I'll bring our first problem out, which is x squared plus 6 plus 5. And let's get Dworsky. How did you do this problem? Guide us on the steps. Okay. Okay. So x plus 5. Awesome. So then our x-intercepts are awesome. Okay. Honestly, how did we do the vertex problem? Mm-hmm. Mm-hmm. You gotta multiply the 1 with something to get -4. Mm-hmm. Okay, take your time. Retrace your steps. Yeah, sure, we could come back to it in a bit. Um, so Haiti, how did you solve this problem? Hello? So Haiti, can you hear me? Okay, yeah. Can you explain how you did this problem? X squared equals 49. So Haiti, are you not able to talk right now? Okay. Dworsky, do you wanna? Your microphone isn't working. All right, try rejoining. Dworsky, do you wanna explain this then? Mm-hmm. Awesome. So we have 7 and negatives. Awesome. Yeah. Um, Anushree, are you good now for the finding vertex question? Did you solve this question? Okay. So IT, is your mic working now? No. Okay. So, okay, I'll just solve it then. Okay. So Dworsky already laid out the foundation. The A value and the C value, they have to be multiplied and they have to add up to the B value. So here, this is our A value, this is our C value, it needs to add up to the B value. So, okay, let's put this into numbers. It has to multiply to 1 and add to -4, right? So is everybody clear on that, how we got to this process? Because I know it was a little confusing for some people. So we all understand why it's A times C, right? And not A times B, for example. Yeah, no, maybe. Okay. So for this question, it's a little harder, right? Because if you see anything that's like multiplied to 1 you automatically like kind of know that you can't multiply anything to 1 and add to -4. So we have to do what's called the quadratic equation, which is x equals b squared minus square root of b minus 4ac, right? I have to can somebody double check for me? It's negative b, no, sorry. It's b squared inside the thing, so it'd be negative b, right, plus minus b squared minus 4ac all over 2a. So this is why I wanted you guys to know what your ABC values are, because now we can just like plug. So we have x equals negative, where b value is -4, plus minus b squared, which is just -4 squared, minus 4, a value is 1, and then c value is also 1, right? Yeah. And then it's all over 2a, which is also just 1. So then we can simplify this to x equals -1 times -4 is just 4, plus minus -4 squared is just 16, minus 4 over 2a, right? Oh, sorry, over 2. So then it's just become x squared plus minus 2. So what am I doing? Sorry. X equals, which is 4 divided by 2, which is just 2. So it's 2 plus minus 16 minus 4 is 12 over 2, right? So that's our x-intercept. Is everybody comfortable with how we got that? Yes, no? Anybody like... Yeah, okay. So these are our two x-intercepts, right, that we found. Now we have to find the vertex. So in a graph, let's say this is our graph, right? Let me better make that. Let's say this is our graph. This is our x-intercept, and this is our x-intercept. The vertex is always in the middle, right? And it's not always the it's not always a y-intercept, because your parabola could look something like this, right? That's why we generally don't use the y-intercept and assume it's the vertex. So from here, we could try using what's called the midpoint formula. So we try finding the middle of these 2 points. So, does anybody know what the midpoint formula is? Yes, no, maybe. Okay, midpoint formula is just a plus b. Okay, so midpoint formula is just a plus b divided by 2. It's to find like the middle between those two, right? So in our case, we have plus minus this. So we would do 2 plus square root 12 over 2 plus 2. So I'll just put a bracket, plus 2 minus square root 12 over 2 all over 2. Is everybody comfortable with how we got these points? Any questions so far? Do you have any questions? Or is it all making sense? Makes sense? Okay. So let's not worry about the division. Let's just worry about adding and subtracting like terms, right? So, what terms do you think we can add and subtract in this? Like combine like terms to make it easier for us. Does anyone want to give it a go? Alright. Can everybody hear me? Yeah. Okay. So I your mic isn't working still, right? Okay, I'll take that as a no. Okay, so since we have these 2 points, this one's fairly easy, right? Like we just gotta look at this. This is plus, this is minus. So they go away, right? It's plus and minus. Easy, right? Because if you have 2 minus 2, it's 0. 3 minus 3, it's 0. So these just cancel each other out. So then we're just left with 2. Okay, x equals 2 plus 2 over 2, right? Which is just x equals 4 over 2, which is x equals just 2, right? But we just want the x value. Hello, welcome to class. We're just learning about quadratic functions. Quick review on it. And do you know what quadratic functions are? Do you hear me? Fahislatu. I'm sorry if I didn't say that right, but are you able to hear me? Okay. That's fine, I guess. That's fine. Okay, so we're just like, if you can hear me, we're just going through how to find the vertex right now. So since we found the x value, we also have to find the y value. Finding the y value is pretty easy. We could just plug it in, right? So y equals, which is just 2 squared, because we found x has 2, minus 4, 2, and plus 1. So I just plugged in 2 wherever we have x's. So then this is just 4 minus 8 plus 1, which is y equals 4 minus 7, which is y equals negative 3. Alright, so then our vertex is at 2, 3. 2, negative 3, sorry. Okay, is everybody clear on that? Ministry, Sohiti Dwarski, Felicia Turo. Yeah, sure thing. So you're comfortable with how we found our x value, right? For the vertex. Okay, so we got 2 has our x value. So all I did was go back to our original equation and plug in 2 for the x's to get the y value, right? So I just did 2 squared minus 4 times 2 plus 1, which got me 4 minus 8 plus 1, which is 4 minus 7, which is negative 3. Okay, all clear? Does anybody else have, good question by the way, does anybody else have any questions? No? Okay, Dworsky, you're also good. Alright. So that was a quick review of quadratic equations, right? And then so there's also word problems, right? With quadratic equations that you have to draw your graph based on that. So let's say a ball, let's say a ball is thrown up at an quadratic rate, right? And this is the only thing we're given. How would you draw your graph where the x-axis is time and the y-axis is height? Okay. How would you think if all I gave you was a ball is thrown up at a quadratic rate with the time on the x-axis and the height on the y-axis? How do you think we would draw this? Any guesses? Anybody want to give it a go? I'll let you guys think about this for a couple of minutes. I'll give like 2-3 minutes and come up with a thoughtful answer. And if you guys need help, let me know, okay? This one shouldn't be too hard. You just gotta visualize it. Does that make sense to everyone? Anushri, Dworsky, Swahiti, all good? Yeah? Okay, awesome. So I'll give you guys a couple minutes. Let me know when you're done. Alright, did anybody else solve this? Does anybody know what to do? Guys? Do you guys know how to graph this? Okay. Anushree, Swahiti, what about you guys? You're just confused on the problem. Okay. So, I'll just help you guys out then, okay? So, we know a ball is thrown up, like quadratic, right? So, it's like, we know the ball, when it's thrown up, isn't moving linearly, right? So, you know how if you, let's say I have this person, right? And they have this ball. If they throw it up, the ball has to eventually come down, right? The ball has to eventually come back to the ground. And so do we see how the height reaches a max? This is what we call max height. Is everybody clear on that? Alright. So when we make our graph, we know that time starts at time equals 0, right? Its height, oops, let me use a different color. So we know that time and height would be at 0 because we are counting this as height because it's being held on the hand, right? Or if you count it from the distance from the ground, your graph would be somewhere around here, right? So we know that he's holding it, and when he throws it up, when you throw something up, it goes like it doesn't move at a linear rate, right? Do we all know that? It starts slowing at the top and then going down really fast, right? We're all aware of this, right, guys? Okay. Yeah, okay. So, like we talked about, there's a maximum height. So we just pick a point, right? Because we don't have any data points. We just have to visualize a graph. So we know the data points would be here. So that would be max height, and it has to return to time equals 0. So it'd be something like this. Or if if you said that this is the height instead of the yellow one, your thing would just be a little, no, it reaches the same vertex, right? So your graph would look something like this. Are we clear on that? So this was more of like a visualizing purpose, because I know some of you would think that quadratics reach the same points. Like if this one went to 0 for the red one, this one should also go to 0. But we can't have that, right? Because that means it's going to negative time, which doesn't exist. And our quadratic has to stop here. Because we can't go into negative height. This is negative height, right? We can't have such thing as negative height, right? So, and negative time also doesn't exist, so we can't graph those two axes. Does that make sense to everyone? Okay. Um, I don't think we have time to learn about what we needed to today. So we're gonna do a quick review of line because that's what next classes will be. It will be the intersection between a quadratic function and a linear function. So let's quickly review a line, right? If this is our graph, a line goes like this. Can somebody explain to me how a line functions? Just like quick little facts about a linear function. Okay, how about this? I'll give you guys 2-3 minutes to think about it, and then I'll start randomly calling people. Okay. Swahiti, since you can't talk, I'd prefer it if you type in the chat. Okay. Because I still want you guys to all learn and stuff. So, 2 minutes, think about some facts, and then I'll call on you guys randomly. Okay? Is everybody clear on that? Okay. Your time starts now. Okay, so I just said that we're talking about linear functions. So I was telling everybody to come up with 2 or 3 like defining meanings of a linear function, like what does it do, how does it work, or like a fun fact about it. Then I'm gonna call on people randomly. And since you can't like talk, I expect you to type in the chat if I call on you, okay? Does that make sense? So yeah, 2-3 minutes starting now. Good luck. Alright, did everybody think of at least one thing? Anushri, Dwarsky, Swahiti. Did we all think of at least one thing? Yeah? Okay. Um, Anushri, tell me one thing about a linear function. Okay. So, what about you, Swahiti? Straight diagonal line. Okay. So they're always a straight line. And Dwarsky, what did you come up with? Oh, okay, so Swahiti already said that. Is there anything else that you could tell us about a graph? Okay, so okay, positive slope. Okay, awesome. So yeah, like Anushri said, the y values change at a constant rate. So if it changed by 2 over here, it has to change by 2 over here, 2 over here, and so forth, right? That's why it's a line. So good job, Anushri. So IT kind of built on Anushi's point. It's like a straight line. Yep, good job, Sohiti. It has to be a straight line because the values are changing at a constant rate. And then Dvorsky told us that it's a positive slope, right? Because it's going towards towards positive infinity, right? This graph is endless, right? So linear functions, these are the main points for a linear function, right? They go up and down at a constant rate. There's also other forms, like if you could have a function that instead of going up is going down, right? This, like adding on to Dvorsky's point, this is what we call a negative slope. The slope is going towards negative infinity. Right. And the general equation for this would be just y equals mx plus b. Right, this is your line equation. And if it's a negative slope, then it'd be y equals negative mx plus b. Y equals this is a positive slope, so it'd be mx plus b. Right? And your b value decides how up or how down your y-intercept is, right? So keep that in mind. And then the slope just determines how steep it is and which direction it's going in. Is that clear to everybody? Yeah, awesome. Okay, so a word problem for this would be, let's say, what are some things that you could get a word linear rate? Let me see. Okay, so you guys know about subscription costs, right? Let's say you have you start going to a gym, right? You start going to the gym. But to start going there, you have to pay a $10 one-time fee, and then $6 per month after that. Right? How would we model that using our equation? Anybody want to give it a shot? Hmm? Okay. Awesome, yeah. Did everybody understand what Nushri said? That was really well said. Everybody get that? Okay. I'm assuming you guys did. That was a very good explanation. Um, yeah, so just like to reiterate what she said, b is a constant value, so it doesn't change. So that's why we have 10 there, because it's a one-time thing, right? You can only go to the y-intercept once in a linear function. And then $6 a month, that's like the rate. Like, say you have a graph with like, 1 month, 2 month, 3 month, 4 month, 6 month, right? It'd be $6 a month. Does everybody understand that? So yeah, that's all I wanted to really cover this class. We talked about um, you know, linear functions. We talked about quadratic functions a lot. We're solving quadratics, finding the vertex, which is going to be useful for our next class. We also talked about the linear functions, how to graph quadratic functions. And yeah, that brings us to the end of this class. So I'll see you guys next week, same time on Sunday. So yeah, you guys are free to go now. If you have any questions, send me a message on WhatsApp and I can help you there.